Hi everyone, Dr. Metter here. Let's talk a little bit about energy, which is our Unit 13 topic. So energy is basically the capacity to do something, the energy to get out of bed in the morning, the energy to do your homework, the energy to ride your bike. In physics, it's specifically the capacity to do work. It's the capacity to do work. And in physics, what we mean by work is changing the energy of the system. And work means the capacity to move an object through a distance by an application of force. Application of force. In mathematical terms, work, which is W, is equal to the force applied to an object that moves it through a distance. Okay, when we think about work, we can think of it in terms of the magnitude of work, which is basically the force times distance. The force, the magnitude of force times the magnitude of the distance. What this does is this changes the energy of the system. It adds energy to the system if work is done on system. And there's a loss of energy of the system, or it decreases the energy of system if our work is done by the system. So let me restate this. If work is done on the system, then energy is added to the system. If work is done by the system, then there's a loss of energy in the system, and that energy goes to some other place. Is transferred to something else that it's doing work on. So, one major concept of energy is the conservation of energy, which you've probably heard a million times, which tells us energy is neither created nor destroyed. It's only transferred. So it can only be transferred from one object or one system to another. And it can also be transferred or transformed into another type of energy. So what are the different types of energy? Of energy. So let's talk a little bit about the other types of energy. Okay, so we have mechanical energy. We have electrical energy. We have chemical energy, one of my personal favorites. We have thermal energy. And we have nuclear energy. Okay. Energy can be transformed from mechanical to electrical, or from electrical to chemical, right? What physics mainly focus on, or physics 1 mainly focuses on, is this mechanical energy. So this mechanical energy is the energy of position and motion of an ordinary object. So that could be a person on a bike or a cart or something ordinary in life that we see all the time. Chemical would obviously be based on molecules and atoms, electrical would be based on electricity flowing, and so on. So mechanical energy looks specifically at the position and motion of an ordinary object. Now, there are different types of mechanical energy that we need to be familiar with. And energy can be transformed from one type of this mechanical energy to another. And that's basically what all our problem solving is based on with energy. So we have gravitational potential energy. And potential energy means it's stored energy. Energy. and you'll see this shortened version as GPE. So potential energy, anytime you see potential, you mean it's stored energy. And for gravitational potential energy, it specifically means the energy due to position in a gravitational field. So here on Earth, we have gravity, which is our gravitational field. So the farther you take that object, whatever you're dealing with, whether it's a ball or a person or whatever, the farther you take it from the center of Earth or wherever your reference point is, maybe sea level, then the more energy that's stored in that object. Okay, so the higher it is, the more energy, the more potential energy is stored in that object. Another type of potential energy is elastic or spring potential energy. And again, we see potential energy, and you'll see that as EPE. We see potential energy, so we know this is stored energy. So this is the energy due to specifically a spring being compressed or extended. So you have an object on a spring, the spring is then compressed, so this energy is stored in that spring and then it can be transferred to that object. Or the spring is extended, which would make it come back toward its equilibrium point. And so that energy is stored in the spring and or the object. All right, so then there's kinetic energy. And kinetic energy is not stored energy. It's actually the energy, that's shortened as KE, the energy due to motion. So, due to motion. So we've stored this energy. We have a ball up high on a hill. It has lots of gravitational potential energy. Then once it starts rolling down the hill, once it starts moving, it starts gaining kinetic energy. And that potential energy that it was storing is then converted to kinetic energy of its motion. Okay, and we'll talk a lot about this when we're doing our problem solving. And then finally, we have thermal energy. And thermal energy, TE, is basically the energy lost to heat. And when you see thermal energy, or when you see energy lost to heat specifically, then it's usually due to a frictional force being applied or work done, usually due to work done by a frictional force. Okay, so when you see friction, you usually have some type of loss of heat or some type of loss of thermal energy happening. All right, so those are the different types of mechanical energy that we will look at and we will use extensively to problem solve. The last concept that I want to look at is power. Okay, so power is actually the rate of change of energy. So how fast this change of energy is occurring. All right, so we define it as P is our power, is equal to our change in energy, and like energy rate, we're looking at it, how fast it's changed, we're looking at it over our change in time. And we know that our energy, actually we didn't talk about this, but energy is always has the unit of joules, okay, no matter if it's potential energy or kinetic energy, it is always joules, and this is per second. So 1 joule per second is equal to a watt, and that is known as W in terms of units. So our power has units of watts, and it's the change in energy over our change in time. The faster the energy is changing over time, the more power your system has. Okay, that's it. That's all I got for our intro to energy. Have fun with the problems. Let's talk soon. Hope you're doing well. Bye.